Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we'll be talking about how do you graph exponential functions, okay? So we talked about different types of function. I've talked about the cubic functions. I've talked about rational functions. We talked about different types in the previous one. I've talked about quadratic functions. I've talked about linear functions and how to graph it. Now in this video, I'm going to talk about how do you graph exponential functions. Quickly, I would advise that before you come to this video, make sure you've reviewed previous videos and make sure you've understood it. And also, if you've not subscribed, you've not liked, you've not shared, I don't know what you're waiting for. Don't forget to click the notification bell so that when I post new videos, you'll be the first person to know. All right, so let's get cracking immediately. We want to graph exponential functions. So quickly, I've talked about exponential function briefly in previous videos, but here I'm going to just quickly remind us about the general formulas, okay? So when we talk about exponential function, a quick reminder. So the general formula for exponential functions is y is equal to a b raised to power x plus what? C. So in this case, in this example here, a, where a can never be equal to 0, okay? A can never be equal to 0, so a can be 1 and above, okay? And this is the general shape of an exponential function. Sorry, the general formula of an exponential function. And also exponential function have general shape or how it looks like. Now, exponential function could be going upwards, okay? So this is what we call an increasing or positive exponential function. So this is what we call an increasing, all right, or positive. So when you see it's going upwards, it's increasing or positive. So similar to the rational functions, you can see you also have an asymptote as well. So, or it can come down as well, okay? So similarly as well, it could look like this. All right, it comes very close to the asymptote, but does not touch it. So this is what we call the decreasing, all right? Or negative exponential functions, okay? So you can see in this case, it's increasing or positive, while in this case here, it is what? Decreasing. And as like I told you, it's going to come very close to it, but it's never going to touch what? The asymptote, okay? All right, so you can see from here that the most important thing to know when you want to graph an exponential function, you need to know how to calculate the horizontal asymptote. And we've talked about that earlier in the previous video when we're talking about rational functions. So I will advise that you go back and have a look at how to calculate or find the horizontal asymptote. Now, before I jump into this, there are 3 important points to note. So there are 3 important points that I want you to keep in mind, that I want you to note. 3 important points. The first point is that you need to know how to find a y-intercept. Okay, so it's very important for you to find the exponential function. You need to know how to find the y-intercept. And like I told you, the y-intercept is the value of y when x is equal to what? 0, okay? Now, after you found the y-intercept, the second thing you need to find, like I told you that we have 2 types, okay? So because we have 2 types, we have the increasing or decreasing. So you need to first determine if the graph you're about to draw is an increasing function or a decreasing function, okay? So you have to determine is the slope, that means the slope of the exponential function. You have to first determine if the slope of the graph, okay? You need to determine if the slope of the graph is increasing or decreasing, okay? So you need to determine is the graph increasing or is it decreasing? Then when you're done with that, the next thing that you have to do is that you have to think about what happens to the value of y as x become large. So basically you have to find the horizontal asymptote, okay? So what happens to the value of y, okay, what happens to the value of y as x becomes large? So technically what we're referring to is how do you find the horizontal what? Asymptote. So now in a rational function, I explain how to find the horizontal asymptote, the vertical asymptote, and the slant asymptote. But now we are talking about an exponential function. I'm going to give you, explain to you how do you find the horizontal asymptote here. I'm going to explain to you how do you find the slope of a graph to see if it's increasing or decreasing. I also remind you on how to find the y-intercept. Okay, so how do you graph this? So quickly, let's jump to that. So we have 5 rules or 5 steps, okay, on how to do this. So the first thing is that you have to write the exponential function in a standard form. So number 1, you have to write the exponential function. So you have to write the exponential function in a standard form. Okay. So, and I told you the standard form is y is equal to ab raised to power x plus c. Okay. So, an exponential function. So, for instance, you could have an exponential function. You could have something like y is equal to 3, let's say 3 raised to power x plus 7, something like this, okay? So this is an exponential function. So in this case, you can see a is 1, b is 3, and c is 7, okay? So you can have something, but you have to rewrite it in an exponential function. Then when you've done that, number 2, the next thing you have to do is that you have to find the y-intercept. So you have to find the y-intercept. So the y-intercept, at y-intercept, x is equal to 0. So that means you have to find a y-intercept. Some textbook, we call it the f of 0. It's still the same thing. So basically where you see 0, you just, where you see x, you just replace it with 0. Then, so remember I told you the first thing you have to find a y-intercept. Now the next step is to find the slope. So the next thing, step 3, we're going to find the slope. All right. So we're going to find the slope. Now, so if the slope is an increasing, okay, if the function has an increasing slope, so it can call an increasing or positive, okay? So if it's an increasing or positive, what you do is that when you substitute 1 into the function, the answer you get will be greater than when you substitute what? 0. So if it's an increasing function, it means that when you substitute 1, the answer you will get will be greater than when you substitute 0. So what I'm saying is that when you substitute 1, okay, your result, okay, your result will be greater. So the keyword is greater, okay? The result will be greater when you substitute 0. So that's what it means. So in the textbook, there are different ways of finding the slope, but personally, I find this easier. Okay, I find this easier. So if I want to know if it's an increasing or decreasing, no matter how complex the exponential function look like, I just substitute 1 into it, I get an answer. I substitute 0 into it, I get an answer. If the answer I get or I got when I substituted 1 was higher than when I substituted 0, then I know it's an increasing function. Now, definitely you can also predict if it's going to be a decreasing. You already know you can predict what the answer should look like. So if it's a decreasing or negative, so you're expecting the opposite in this case. So basically, when I substitute 1 into the question, the answer is going to be less than when I substitute 0, okay? So it's going to be less than when I substitute 0. So when I'm saying that when you substitute 1, so when you substitute 1 into the function, your result, okay, the result you're going to get will be less than this time. So the keyword here is going to be less than when you substitute 0. Okay, so the key thing here is that to find the slope, when you substitute 1 into the function and the answer you get is greater than when you substitute 0, it's an increasing function. And when you substitute 1 and the answer you get is less than, it's a decreasing function. All right, so step 4. All right, so after you found if it's a positive slope or a negative slope or an increasing or decreasing, the next thing you have to find is the horizontal asymptote. So here, it's very easy to determine the horizontal asymptote here, okay? So if you remember, if you look at the general formula, so remember I told you that the exponential form is y is equal to abx plus c. Now the horizontal asymptote is always at c. So when you write it in the standard form, the value of c you have here is the horizontal asymptote, okay? So in this case, the value of c, the horizontal asymptote is at c, okay? Okay, so the horizontal asymptote here is at C. So what you'll be expecting is that when you write it in the standard form, the value you have here, so if, for instance, I'm plotting this graph, I'm sketching the graph, the horizontal asymptote for this exponential function will be 7. Then when you've done that, easy. The final step, you then sketch the graph. Okay, so the final step, you sketch the graph. All right. So that is it. So that are the 5 steps for how do you sketch an exponential graph. So what I'm going to do now is that I'm going to pick some examples so that we'll be on the same page. So it's very easy. Exponential graphs are, I think, the easiest. It's one of the easiest to sketch. All right. So let's go. So let's say we have this question. We're told to sketch the graph. We're told to sketch the graph f of x is equal to 4 raised to the power x. Now, that is it. We're told to sketch this graph. So remember, when you have f of x, it's still the same thing as saying y is equal to 4 raised to the power x, okay? So now let's start with the first one. So let's go with step 1. So what is step 1? We're told to write this in a what? Exponential in the standard form, all right? So we have to rewrite that to the standard form. So I remember the standard form for this is abx plus c. So let's go back. Let's do that. So that means we're going to have y will be equal to 4x plus 0. Are you seeing it? So that means in this case, our a is 1, our b is 4, and our c is what? 0. So we're putting it in the standard form. So when we're done with that, we're going to go to step 2. Okay. So step 2 now, what's step 2? We need to find a y-intercept, and that is at x is equal to 0. So we need to find a y-intercept. So we know that at y-intercept, okay, we know at y-intercept, x is equal to 0. So basically what we're going to do is that we're going to have y is equal to, so anywhere we have 4 raised to the power x plus 0. So anywhere we see x, we're going to put 0. So we're going to have y is equal to 4 raised to the power 0 plus 0. Now, remember that anything raised to the power 0 will be equal to what? 1 from the loss of indices. So that will give us 1 plus 0. So therefore, y will be equal to what? 1. So that means we can now say when x is 0, y is 1. So this is the what? The y-intercept. Good. Now we've drawn the y-intercept. Step 3, we need to find the slope. So we need to determine if the slope is increasing or if the slope is decreasing. And the best way to do it is to substitute 1 into it. When you substitute 1 and when you substitute 0, if the answer when you substitute 1 is greater than when you substitute 0, so it means that it's increasing. And if it's the other way around, it's decreasing. So now we need to find the slope. Step 3. We need to find the slope. So we need to first find f of 0. So that means it's going to give us, anywhere you see x, you put 0. So it's going to become 4 raised to the power what? 0 plus 0, and that will give you 1. Okay. So anywhere you see x, you put 0. Then you're going to put f of 1, and that will give us 4 raised to the power what? 1. So anywhere you see x, you put 1 plus 0. And that will give us what? 4. So from this, now you can see the answer we got from f of 1 is greater than the answer we got from f of what? 0. So therefore, if you go back, when f of 1 is greater than f of 0, it means it's going to be what? Increasing. Okay? And increasing, remember I told you increasing means the graph is going to look like this. Are you seeing it? And decreasing, it means the graph is going to look like this. So the decreasing means it's coming down, increasing means it's going up. So that means we'll be expecting this graph to be what? Increasing. So we're expecting this graph to be has an increasing slope. So we're expecting the graph to look like this. So it should be going up. Is that making sense? All right. Then the next one, step 4, we need to find the what? Find the horizontal asymptote. And we're told the horizontal asymptote is at C. All right, so let's go back. So the horizontal asymptote. So what is our C here? Our C is 0. Are you seeing it? In the standard form. So therefore, the horizontal asymptote will be equal to what? 0. Okay, so we have all what we need to draw the graph now. So let us sketch the graph and see what we'll get. All right, so let's draw it. Step 5. So let's sketch the graph. Okay, so we have everything we need. So we have draw the graph. Okay, so this is the y and this is the x. So let's say this is 1, this is 2, this is what? 3. So the first thing is that the horizontal asymptote is at 0. So let's draw it. So the horizontal asymptote is at 0. So the dotted line is going to be on the x-axis, okay? Because the horizontal asymptote is at 0. Then the next thing as well is that we also know that the y-intercept is 0 and 1. So it's going to be 0 and 1. So here it's going to be 0 and 1 to the y-intercept. And also we know that the graph is meant to be increasing. So it's going to look like this. It's going to go all the way from this all the way up. So this is going to be the equation for a y is equal to 4x. Y is equal to 4 raised to the power x. So this is the equation y is equal to 4 raised to the power x. And that is that, okay? And that is that, okay? All right, so let me pick, maybe I'll pick 1 or 2 more, all right? So we can try. So what I would advise is that in this next example, I want you to just pause the video, try and solve it yourself, follow the 5 steps and see if you can sketch the graph, okay? So let's go. So let's sketch the graph. So assuming you have y is equal to f raised to the power x plus 1, for instance, and you were told to sketch this, all right? So let's go. So you can pause the video, and when you're done, you can come back and have a look, all right? So let's start. Step 1. So we have this. We're told step 1, you have to write it in the standard form. So if you look at this, it's already written in the standard form for you. So we have y is equal to 5 raised to the power x plus 1. Okay. Then after writing it in the standard form, step 2, we need to find the y-intercept. Okay, so we need to find the y-intercept. So step 2, we know the y-intercept. At y-intercept, x is equal to what? 0. X is equal to 0, okay? So this kind of exponential of graph, you're going to deal with more of this type of graph when we talk about, you can see transformation between graphs, and you appreciate the sketching. So sometimes you're not really sure, you can just quickly sketch it. So you can now see, oh, how the graph transform from one different function to another different function, okay? So let's go back. So we have at y-intercept, x is equal to 0. So that means anywhere you see x, you put 0. So we have y is equal to 5x plus 1. So it's going to become y is going to become 5 raised to the power 0 plus 1. And n raised to the power 0 is equal to 1. So 1 plus 1, and that will give you what? 2. So that means we can say when x is 0, y is what? 2. So we found the what? X-intercept. Sorry, the y-intercept. Then when we're done with that, we'll go to step 3. So step 3, what is step 3? We're told that in step 3, we need to find if it's increasing or decreasing. All right, so we're going to find the slope. So we're finding the slope. So to find the slope, we'll have to find a function, substitute x is equal to 1, and substitute x is equal to 0, and see if it's greater or less than. If it's greater, it's increasing. If it's less than, it's decreasing. Okay, so let's go. Let's solve this. So we're going to start with f is equal to 0. So anywhere you see x, you put 0, and that will give us 5 raised to the power 0 plus 1. And this will give you 1 plus 1, and that will give you what? So 5 raised to the power 0 will give you 1 plus 1, and this will be equal to 2. Then f raised to the power 1, it will give you the same thing. So it'll be 5 raised to the power 1 plus 1. 5 raised to the power 1 will give you 5 plus 1, and that will give you what? 6. So you can see the answer from f raised to the power 1 is greater than the answer from f raised to the power what? 0. So that means because it's greater, this is going to be an increasing. Are you seeing it? It's going to be an increasing slope. And that means when you're going to draw the graph, you should be expecting the graph to look like this. Okay? You should be expecting the graph to look like that. Okay, so we've done with that. So let's go to the next one, step 4. So step 4, we're told to find the horizontal asymptote is at C. So we'll go back here. So you can see from this point here, we know our A is equal to 1, our B is equal to 5, and our C is equal to 1. Okay, so we talked about this earlier. So because you know that the general form for is A, B, X plus C. So we had 5 raised to the power X plus 1. So that means the A is 1. Okay, so remember, if there is nothing here, there's 1 there. Then the B is 5, and the C is this 1 here. All right. So therefore, the horizontal asymptote, we're told that the horizontal asymptote is at C. So the C we had here is 1. So that means the horizontal asymptote will be equal to 1. Okay, the horizontal asymptote is equal to 1. So now we have all what we have now, so we can go to step 5, which I believe is sketching of the graph. So we'll see how we want to sketch this graph now to see. All right, so let's sketch it and see. So we have step 5. We want to sketch, so we're going to draw the graph. Have something like this. So we have 1, we have 2, we have 3, all the way to y, and that's for that. So let's start. So the first thing we know here is that we know the y-intercept. The y-intercept is at 2, okay? So the y-intercept is at 2, okay? And also we know the horizontal asymptote is at 1. So the y-intercept was at 0 and 2. The horizontal asymptote is at 1. So we'll be expecting that the horizontal asymptote will be here. Good. And also we know that it's going to be an increasing slope. So that means we'll be expecting the graph to look like this. It's going to move all the way through this and go up. So this is the graph. And that will be the answer for that. Okay, so I'm tempted to just add one more. So let us try one more. It's going to be similar. So what you can do as well, you can just pause the video, all right, and try and draw this yourself. So let's go. So let's assume we were told to sketch, okay, sketch the graph. We have f of x is equal to 4, 0.5, all raised to power x. Okay, so easy. Let's do this. So like I said, you can pause the video, try and solve it yourself, then you can come back and see if you get exactly the same thing. All right, so let's go. So step one. So if you go back, so step one is that we need to write it in an exponential form. So we can go back and do that. So that means we'll have y will be equal to 4, 0.5 raised by x plus 0. Are you seeing it? So that means in this case now, we know our a is going to be equal to 4, our b is 0.5, and our c is what? 0. Are you seeing it? Good. Now step two. We're done with that. So step two, we need to now find the y-intercept. So as usual, we know the y-intercept. At y-intercept, okay, x is equal to 0. So it's going to become y, it's going to become 4, 0.5x, and that will give us 4, 0.5 raised to the power 0. Are you seeing it? Anything raised to the power 0 is equal to 1. So it's going to be 4 times 1, and the answer is going to be 4. So that means x is going to be 0, y is going to be what? 4. So this is the x-intercept, sorry, the y-intercept for that. Now, the next thing is that we're going to go to step 3. So for step 3, we then have to now, I think the slope, yes, we'll have to find the slope to see if it's decreasing or increasing, all right? To see if it's decreasing or increasing. So let's go and check it out. So, and the best way to find it is by substituting f equals to 1 and substituting f is equal to 0. If it's f equal to 1 is greater than 0, it will be increasing. But when you substitute 1 and the answer you get is less than when you substitute 0, it means it's decreasing. All right, let's go and check it out. So step 3, let's first start with f of 0. So f of 0 will become 4 into bracket 0.5 raised to the power 0, okay? And when you press your calculator, the answer you will get here is 4 because 0.5 raised to the power 0 is 1. 1 times 4 will give you 4. Now, when you press f of 1, so the same thing is going to give you 4 and give you 0.5 raised to the power 1. The answer you will get is going to give you what? 2, because 4 times 0.5 will give you 2. So you can see that f of 1 is less than f of what? 0. So because f of 1 is less than f of 0, so it means this is going to be a what? A decreasing what? Slope. All right. So that means when we want to draw this graph, we should be expecting the graph to have to look like this. Because it's what? Decreasing. All right. So the next one is that we're going to do step 4. So step 4, we need to find the horizontal asymptote. Yes, we need to find the horizontal asymptote, and it's at C. So what we're going to do is we're going to, what is the C value here? It's C is 0. So therefore, the horizontal asymptote is equal to what? 0, because the C we have here is 0, okay? And that is that. So now we can now sketch the graph. So let's sketch the graph. So that is step 5. Let's sketch it. So we can draw this here, draw this here. Bring it down a bit, draw this here. So we have 1, 2, 3, 4, 5, 6. So the shape can look in different ways. So based on the values you get will determine how the graph will look like. So here we know from this point, we know the y-intercept is at 0 and 4, so we're expecting it to be here. This is the y-intercept, 0 and 4. Draw this well. So y-intercept is 0 and 4. Then the next thing as well is that we know the asymptote is at 0. So that means we're expecting the asymptote to be on the x-axis because it's 0, okay? All right, we're expecting it to be what? Decreasing. So we should be expecting the curve to come this way, all the way down here, down this. And that is how the curve will look like for that. All right. All right. Thank you very much. And this will bring us to the end of this series. I hope you found it very helpful. Please try as much as possible to review previous video. If there's any questions, try textbook questions, try questions from the worksheet. And if you don't understand, feel free to stop me anytime, send me an email, or put it in the comment section. I will have a chat about it, okay? Thank you very much, and I will see you in the next video, all right? And if you've not subscribed, I don't know what you're waiting for. Don't forget to subscribe, share, and like so that you can click the notification bell. So when I upload new videos, you'll be the first person to know. All right, see you soon. Have a nice day.